Yeah, welcome to Steph's Academic Tuition Center. With me here is a question for physics and a simple machine. So the question reads, figure 4.1, which is this one, this is 4.1, shows a wheel and axle. So I have a wheel here and the axle. So this is axle, this part is called axle here. And this part here is called a wheel. Good. So you need to know how to label this part. In fact, this is axle, this is a wheel. So the axle and the wheel system used to lift a load of, so as you can see, the load here is this one, okay? Load is equal to this one. A load of 2,000 Newton through a height of 4 meters. This will be our height. Our height, this is our height, which is our distance. The work done against friction is this one. So work done against friction is this one, which is 2,000. So joules. So the question reads, the first part. So before that, maybe we can take note the following. We'll talk about the effort. As you can see, there's effort here. We say effort is the force applied. Apart from that, you can say the effort moves through a distance equal to the circumference of the wheel. So which means we can say the effort moves through a distance to the circumference of the wheel. And the load, this load, as you can see, it moves it through a distance equal to the circumference of the axis. As you can see, this is the axle, so the circumference here 3 centimeters, which means the distance moved by the effort, by the load. And here the distance moved by the effort is for the wheel. So distance, as you can see, the circumference from here to here is the radius, then from here to here the circumference. So I'm saying that the load moves through a distance equal to the circumference of the axle, and the effort moves through a distance equal to the circumference of the wheel. Then the first question reads, so I'll say solution here, put solution here, question A. So question A, they're saying that calculate the velocity ratio VR of the system. So talk about VR, we say VR is equal to, as you can see, I said the effort moves through a distance equal to the circumference of the wheel. So which means we say the big R over the small r. So always when finding the velocity ratio under this type of machine, you just need to write the formula. VR, which is velocity ratio, is equal to a big R, which is big radius, the radius of the wheel over the radius of the axle. So VR is equal to, so the big R, as you can see, is 12 centimeters, so write 12 centimeters over the small r is 3 centimeters, so you write 3 centimeters here. Then since we have centimeters and centimeters, so cancel each other. So VR is equal to, so 3 into 12, the answer is 4. So VR, it has got no sign because the centimeters will cancel each other. So this is the final answer for the velocity ratio. Then we'll go to question B, which is the efficiency. Question says, find or calculate the efficiency. So on this one, we need to be very careful. We know that efficiency, there's that formula which says efficiency equal to mechanical advantage over velocity ratio times 100%. Now, since, yes, quite right to have the velocity ratio, now we don't have mechanical advantage, because we know that mechanical advantage is load over effort. So in this case, we don't have the mechanical advantage. So for us to find the efficiency, we are going to use this formula. So take note, this question B. Question B, I will write from here. So I'll say efficiency, F is equal to, so I'll say work done by load over work done by effort times 100%. So we'll say efficiency is equal to work done by load over work done by effort. So which means for me to come up with a work done by effort, I mean by load, I'll say work is equal to I know work is equal to force times distance. So if I want, I can say I can use the work is equal to force times distance, or work is equal to load over distance, or work is equal to weight, which is the pull or push acting on an object. So work is equal to load times the distance. So the distance here, which means I'm going to use the height given. So according to my diagram here, as you can see, my load here is this one. So which is what? 2,000 times the distance given, which is the height, which is what? Which is 4 meters. So I multiply this times this, I'll get 8,000 joules. This will be my work. So work done by load. Then again here, work done by effort. So don't forget that work done by effort is equal to, so pay attention here, work done by effort we say is equal to work done by load I mean, plus work done to overcome friction force. So don't forget, we're saying that work done by effort is equal to work done by load plus, which means we're adding, plus the work done to overcome frictional force. So now, work done by effort is equal to, so work done by load, which is 8,000, then plus the work done to overcome friction force. In the question, it was mentioned in the question, the work done against friction is 2,000. So it means we're going to put 2,000 here. Then now we add. So work done by effort is equal to 10,000 joules. This is the work done by effort. So now we go back to the formula here. Efficiency. We know that efficiency is equal to work done by effort, by load here on top, over work done by effort, then times 100%. So work done by load is 8,000, so it is 8,000 over work done by effort is 10,000, then times 100%. So when we multiply this 8,000 over 10,000 on the calculator, then times 100 to give you what? 80%. This will be our efficiency. So please pay attention. This question is very tricky. So you need to pay attention to each step taken, and the formulas here. So work done by effort is equal to work done by load plus work done to overcome friction force. Don't forget this part. This part is very interesting, in fact. Then work done by effort, which means we add this work done by load plus the work done used to overcome friction force, which is 2,000 here. Good. Then you add this plus this, which is 10,000. So now come here to the formula for efficiency, which is work done by load over work done by effort times 100%, and the final answer is 8%. Then the last question says, so okay, due to space, okay, I can solve it from this end, from this end. Question C. Good. The work done. The question says, find the work. Find the mechanical advantage. So since we know that, okay, due to space, I'll use this part. Since the question says find the mechanical advantage, since know that mechanical advantage is what load over effort, but we don't have effort, we don't have load. Okay, load we have, but don't have effort. So we're going to use the formula. Question C: efficiency is equal to mechanical advantage over VR times 100%, like this. So our efficiency is 8%, the one that we've calculated here, which is 8%. So I'm going to get this 80%, 80%. So put 8% here is equal to mechanical advantage. We don't know if we are going to put X over the loss ratio calculated is this one, which is 4. 4. So 4 times 100. So we're going to say 8 is equal to over 1 here. Over 1 here. So we're going X times 100, we're going to find 100 X over 4. Over 1, cross multiply. 1 times 100 to give us 100 X is equal to this and this to 320, then over 100, even over 100, so it means X is equal to 3.2. So our mechanical advantage is equal to 3.2 as a final answer. Thank you very much. Don't forget to like the channel and subscribe. May God bless you abundantly.